do number 10, you are looking at it and it says, okay, 10% of the people in the 18 to 25 actually vote. So they put this as 0.1A plus 40% of the people in the age group from 26 to 64 vote. And if we are looking at people 65 and older, 50% of them vote. And they said, well, what would be the percent in this case? Predict the percent of voters that are in favor of this bond issue. Like if you usually need to get 50% to pass, would this pass if we are looking at it? Or what percent would we get? So what you're actually doing is you're taking 0.1 and the people that supported it was 79. Plus, if you didn't have this down for number 10, make sure you write this so I can see how you calculated it. 0.4 times 55 out of our 100 people voted to say they would support it. And in the last group, not many of our seniors are supporting this. So this is a lot of times what you might see happen in communities when they're trying to get something passed, because a lot of times maybe your older voters, you know, it doesn't affect them. They don't have kids in school. So what do we get for a percent when you put that in your calculator? So grab your calculator, 0.1 times 79, 0.4 times 55, and 0.5 times 33. And like I said, this is very similar to how you calculate your semester grade. It's very similar to this. What do we get for a percentage? Would this pass? What'd you end up with? 40. What'd you guys get? 0.1 times 79 plus 0.4 times 55 plus 0.5 times 33. Should have came out to equal 46 what? 46.4. And so young people might be really surprised that this didn't pass, right? 79% of them voted for this, but not many people vote. Only 10% of the people voted in that age group, right? 10% of the people that were eligible to vote only voted. So even though a lot of people might have been in support of whatever this issue was, because more people voted, 50% of our elderly were voting, and they voted no, it didn't pass, right? So that's something that we're looking at. Right now, Fargo Schools is going forward with trying to figure out how we can get people to vote for an issue coming up. If it goes something like this, it's definitely not going to pass. So how do you figure your semester grade? Because it's getting really close to the end of the semester. This is what you want to write down someplace in your notebook or someplace. You are taking 0.4 or 40% of your quarter one grade plus 0.4 times your quarter two grade. And then it is 20% of your final exam. So when I go to calculate what your semester grade is, you right now already have your quarter one grade. So let's just think, oh, you know what? You had a 93% quarter one. So you're going to take 0.4 times 93. Quarter two, you've done about the same, but you've struggled a little more. You're sitting at a 92%. Some of you might be at an 82%. I don't know. Plus, now you're taking 20%, and if you have a 93 and a 92, what happens if you get an 82% on your final? What grade are you going to do? Put this in your calculator right now, please. So 0.4, you don't have a calculator, I asked you to have one for the first one. There's calculators up in front. Grab one, get one, so you can do this. 0.4 times 93, 0.4 times 92, 0.2 times 82. I'm telling you what you get it to equal. What'd you end up with? 90.4. Just barely got that A, 90.4, right? If you would have changed this from an 82, and so what you want to do is you want to go in and put your percents that you got. You really, at this point, have these two grades. Are we done with quarter two? No. You just got today's test that you're from last week in there. We will have a test on this unit, okay? And we will have probably like a project that we're working on. So this grade isn't finalized, but if you're kind of looking at what you had right now, you could put that in. and see what's the lowest you can get. Now, if you're sitting at like a 95 and a 93, I bet you can get even lower than an 80% on your final and still get an A for the semester, okay? So I'm not trying to get you to discourage you from studying, but some of you, this is going to be like a make or break. I have a couple people that are really close to that 90%. They really want to get an A in this class. If you're right here, then definitely you want to put that extra time in. If you're at a 95 and a 95, you can probably, I mean, you want to study for the final, but you don't have to get majorly stressed out because you can probably get even a 75% if you have a 95 and a 95 and still end up with an A because that's 20% of your grade. But that's how you calculate it. So you can kind of put in the numbers that you have for your grades and see what do you need to get a 90% and put in different numbers and see how you do. Put your scores that you have and say, oh man, what do I have to do to get this quarter grade up or what do I have to do, okay? This is where we left off last week, okay? So please turn in your notes. This is where we left off with relative frequency. We did this table, right? We talked about the total, okay? So this is on your notes. We are looking at just those last two. So problem 3, we need to keep referring back to problem 3. So this is the problem 3 that you're going to refer back to. And on the next page of your notes, we are looking at the row. So when you go across, this is called your row relative frequency. And when you go find the numbers going down, this is your column. Okay, so just to make sure it makes sense to you when we're talking about a row goes across versus the column. So notice the numbers in this table. And what you are asked to do is to calculate the relative frequency first of the rows. That means you want to go across. So this one is looking at our rows. Okay, so up here, this is the rows going across. Here, we're looking at the columns. That means going down. So when I look at going across, I look back at the number of men, which was 20. The number of women was 30, and this was 50. Okay? So to get that first number, they took 2 divided by 20, then 10 divided by 20, and 8 divided by 20. So to find this number, we are now looking at taking 10 right here and dividing it by 20, which is 0.5, right? Here we are looking at taking 8 and you're dividing it by, there's 20 men. And this one back here, you're taking 20 divided by 20. Get your notes there. So turn to the next page so you're on the right spot. So this is 1.0. There were 30 women total that were surveyed. This is going to be 1.0 because you're taking the 30 women and dividing it by that total 30 by 30. This is also going to be 1.0. Why? Because you're taking the 50 and you're dividing it by 50 if you go by the row. How are we figuring this number? If we look back at the number of women, that was 16. And we're dividing it by, not by 50 this time, but by 30, the number at the end of this row. So please calculate these and kind of check with your shoulder partner. Well, put your calculator. The next one you're calculating is that 6 out of 30. And as we look at these percentages, it is important that they kind of add up going across. So I have 0.1, 0.5, and 8 divided by 20 actually does come out to be 0.4. So that if I add 0.1 plus 0.5 plus 0.4, if I add going across, right, it has to total to 0.1 plus 0.5 plus 0.4 has to equal 1.0. So when I'm looking at this one and I put 53%, 0.53, and then this one is, if we were looking at it, you get 20%, 0.2. I know that when I'm looking at here and I get 2.66, I'm gonna go to 2.7, right? Does that make sense that I'm at 27? So that when I look at those numbers, 0.53 plus 0.2 plus 0.27 gives me the 1.0, right? So this has to be my 100% of that. Did this row change from the original one? From the last relative frequency? It shouldn't have, right? All of these numbers going across should be the same because you were dividing 18 by 50, 16 by 50. So if we were looking at that last column, all of those should be exactly the same if we are looking at those. So 0.32, we're going to have the 0.32 and 0.36. So this time, where is our 1 or 100% going to be? It is going to be on the bottom of each of these. This is going to be 1.0 for the TV watchers, 1.0, 1.0 going across. Which means my total number that I was looking at when I was doing that problem is I went back and I had a total of 18 that chose dance, right? So this was 18. So here I was dividing 2 by 18 to get this number. The number of women that chose dance was 16, so I'm taking 16 out of 18. Do I have to divide 16 by 18 if I know this is 0.11? What could I do, Owen?
Well, you can just subtract
From 1 and give us 0.89. Okay? So if I figure one of them, so if I look at the sports and I have 10 and I divide that by my total at the bottom here was, I think we had 16 and 16. If I take the 10 and divide it by 16 again, and I get that percentage, 10 divided by 16 gives me 0.62. If I'm looking at that, I know I can subtract 1 minus 0.62, and I should have, if I was looking at that, 0.38. The common mistake that sometimes all the people go 48, but it is 38, because 38 and 62 add up. Okay? And what happened with our TV, if we were looking at that, they both came out to be exactly the same, right, at 50%. And here we're dividing by 50, so we still have that being our 0.4 and our 0.6, just like we did in the original one, okay? So the question then is going to ask you to describe some patterns in your data. So as we look at that, I want you to write, if we are looking at men versus, if we're looking at men versus women, I want you to write a statement with the percentage of men picking an activity versus the percentage of women picking the same activity, okay? So if we are doing that, we're looking at out of all of our men and out of all of our women. So if we are looking at that, an example might be, looking up here, 10% of all men chose dance, right? Versus 53% of all women chose dance as their favorite activity, okay? If we were looking at a specific activity going down, okay? So of all the people that chose dance, all that chose dance, we might make a statement like 11% were men and 89% were women. So 10% of all men chose dance, but here, of all the people that chose dance, 11% were men. Does it make sense how we're using these different percentages, the 53 and the 89? Here we're talking about all the people that chose dance. So we're looking just at this column, so we're using the 11 and the 89. Here we were talking about, of all the men, 10% of the men chose dance. Whereas here, of all the women, 53%. So you kind of got to be specific as to here, 10% of men and 50% of women chose dance from all men or all women if we were looking at it, versus here we specified of all the dancers, right? Of all the people that chose dance. So the key thing is as you're looking at your homework, is looking at what are they telling you it is from. So here's a two-way table. As you look at this two-way table, they're telling us our totals. So as we look at our margins, okay, 92 people were surveyed. So as you look at this information, they want us to figure our percents. And the key thing I need from you is I need for you to tell me first, because some of those percentages don't quite work, is how did you figure out what percent of children are at the movies were male? So what do we want to be dividing by when I look at that first cut? What do I want to divide by? What do I want in my denominator? Do I want 38? Or do I want 39? What is my of all children? I should divide by 38. Does that make sense? I want to divide all the children, then we're male. So now I'm going to go back, and how many were male? 15, right? Put that in your calculator, please. And how many you got? 0.39. So if it says what percent, we're going to change 0.39 to be 39%. Okay? When I read this one, of females, what should be in my denominator as I look at that?
54.
So of the females are adults. So in this one, when we did of children, we had 38 in our denominator. If we're going of females, we should divide by 53. At the movies for adults, so of those, I am now going to divide by, put in 30, right? What'd you get, Oren?
0.57.
Of males, Abby, what are you thinking? At per adult. 24 over 39. Gives us what percent? 62 over 100. Okay. Samantha, what percent of adults at the movie were female? Divided by what?
54.
Divided by 54. And I should have 30, right? Am I right? Which gives us 56%. What percent of people at the movie were children? Brooke, what should I divide by?
92.
Divide by 92. We're talking about everyone that was there. And Joey, what number should I be putting for my children?
38.
38. So I'm looking at all children from both sexes. So we should have what you end up with, Joey? 41%. 41%. It says write sentences describing at least 2 facts. Use at least 2 facts up here to support your answer. So I want you to think right now, and I'll get
Only 41% of them were children.
so stating it what? Majority of the people. And that's pretty much saying the same thing. The majority of the people at the movies. At the movie are adults. And then just restating 59% versus 41% children. Anyone have a different statement if we aren't looking at the total? That would give you something else. When you look at that, would you say that there are more, were there more females at the movies when we went, or more males? At this moment. There's definitely more females, right? Could we write a percentage question with that? That wasn't one of ours, but of the females that we had already that 57% of them were adults. So we could say of the females in attendance, 57 were adults, and then we would be able to go with 43%, right, were children, because they have to add up to 100%. Could we have looked at of the total adults at the movies? That, again, there are still more females going than adult males that were going to this one, right? There were more female children that went than males. So maybe it was a big Disney movie and it wasn't Star Wars or something like that that came out, right? I mean, it might mean what's opening for your movies that they looked at, okay? So you are finishing the page 760. If you have 760 done with the number 10 that we did, you can turn that in. You are looking at the first ones, questions 1, 2, 3, 4. You're just kind of filling in. Again, look at the back as you do a few of them. The answers are right behind the worksheet. So as you're checking them, kind of make sure that they make sense. I mean, you could always ask me, like, I don't get why they put, the 71 or the 21 where they did. But take a look at it first so that you can figure out the 4 numbers and then plug in what you need. I believe you don't have to start doing relative frequency till, I think it was question number 6. Make a two-way table, include row and columns. Where they start asking you to make those relative frequencies. My hint is, as you're doing that next part of it, again, if it helps you to put in the total, I would do that with each of these so that as you look at it, you can make sure you're figuring those out as you go. So there's kind of that first part and second part as you are doing. When you're looking at like the Venn diagram ones, to look at that one, to think about how we are looking, that was back at that question 9, and it says, construct a two-way table to display this. What is the relative frequency of the number of students that jog and do aerobics, total number of students, round the necessary ones. So making sure that you're making the right kind of relative frequency tables. Here too, construct a two-way table first that show the frequencies by columns. What is the relative frequency of the number of girls? So keeping in mind that when you are going down, that is your columns. And when you go across, that is your rows. So just as you look at those, okay? So when you do this one and you're thinking about just making the table, the two-way table, it doesn't matter if you put jogging or aerobics on the side, but if you put jogging, right, then you're going to have not jog. So it's the people that jog, the people that do not jog to your total. It's going to be your aerobics to your not aerobics to your total, okay? Keeping in mind that there's these 5 people out here, right? When you read that Venn diagram and how to look at that. So the rest of the time is yours to work on